Lowest batting average I've seen yet.
There's still time. I have faith. Well, that means that yesterday's lecture was really bad. All right. What are we going to talk about today? Automation. I should have just had you guys watch the video, huh? Little professor humor. You guys are, you know, you're supposed to laugh at my jokes, right? And you just don't care. What time did you get up this morning? 7? It's been an hour. Who got up before 7? Who got up before 6? Who got up before 5? Wow.
Did you sleep?
Yep. 4:45. So that I can get here for 6, so that I can be ready for this lecture. Because it takes some time. It doesn't look like it, but it takes some time to get ready for lecture. So who's got some sort of a device that could see the internets? Is there anybody that doesn't have some sort of a device that could see the internets? All right, go to me1800.com. Should be easy to remember. me1800.com. Right at the top, there should be a link that says Survey 1. I was thinking I might be more than one survey, so I named this one Survey 1, but I only actually made the one. Go to me1800.com and answer the question, the one question, which is a one-word answer on Survey 1. And I'm going to see if I can pull up the responses here. me1800.com. No? Maybe I didn't click publish. Oh, let me go back and fix it. me1800.com. Right at the top of the page, it should say Survey 1. But that could totally be on me because I was all excited about making the survey. I may not have clicked publish. Let me get back in here. Edit your website. Come on. At least it's not on Facebook, huh? No, I don't see it either. Okay, let me try one more time. View the page. Edit the page. Add a paragraph. Wow, this is like watching the sausage get made, huh? Well, except I'm not projecting it. Yeah, that's because you can't see it. But I can. I have an easier way to do this. I'm going to go to the syllabus. But wait a second, because you're going to have to click refresh if you go right now. Syllabus and edit mode. Yes, leave this page. Go to lecture schedule. Go to the lecture for today, which should be titled Manufacturing Automation. And SURVEY and make that a link. This is exciting. Not. Now I'm going to the page that I need a link from. Form. This would have been way, way cooler if I had actually clicked submit on the other computer. All right, back over here and paste. Apply. Now I think if you click refresh on that page, this one, this page, if we click refresh, this is a link that says survey. Click that survey. It says, what is the first word that comes to your mind when I say manufacturing automation? Very anticlimactic. What is the first word that comes to your mind when I say manufacturing automation? Let's see. What is the first word that comes to your mind when I say manufacturing automation? Look at that. No, I don't want to submit another response. I want to view. Oh, come on. All right. Tools. View responses. There's a button. Only 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's more than 9 of you here. And there's more than 9 of you watching live. So click submit. Let me click refresh. 16. Still 16. 17. Oh, I don't have to keep clicking refresh. It just updates. It's exciting. Almost as exciting as watching paint dry. All right, let's start looking at the responses. No cheating. If you haven't answered yet, don't look at the responses. I got 3D printing, assembly line, robot, robotics, robots, Teradyne. Cool. If you don't want to remain, if you want to remain anonymous, just stay silent. Why Teradyne?
It could be online.
They could be online. That's why I said stay silent also. Come on, wake up. All right. What's the theme? What's the theme? Have you been trained to think that robots mean manufacturing automation? So if you visualize a robot doing manufacturing, what do you picture? That was the answer I expected, by the way. Thank you for meeting my expectations. Ooh, according to the official WPI grading scheme, if this was your MQP, you would have just gotten an A. No, you would have gotten a B. B is meets expectations. C is A is exceeds expectations. You have not yet exceeded my expectations. So if you want to get an A, what is the image that you have in your mind when you say robot with association of manufacturing education, automation, or education? I don't care. What's the picture? Somebody. Yes.
Like auto assembly line.
An auto assembly line, right? So you see that robot and maybe it's moving a chassis or maybe it's welding along the frame of the automobile. Maybe it's putting a seat in the car, like it's placing the car chassis is rolling down the assembly line and the robot is reaching in and putting in a seat, putting in the windshield with the suction cups holding the glass there and go and then right? Like you've all seen these images on the TV, on the internet. What's manufacturing? So I get it. Robots came into manufacturing primarily in the auto industry. That's what we've seen. We've seen pictures of this. It has brainwashed us. That's actually how brainwashing works. If I keep showing you the same thing over and over again, you will believe that it's true. If you keep telling yourself the same lie over and over again in your head, you will believe that it's true. It's how brainwashing works. We've been brainwashed to believe that manufacturing automation means robots. But what is manufacturing? We've been studying what is manufacturing the whole term. What is manufacturing? Making stuff. Making stuff to sell. So if we picture robots building cars, when we think of automation and manufacturing, does that encompass making stuff to sell? Really? I see nods. So it's included, right? So it's like the math things where you have like the, what's this? We call it a Venn diagram. The reason I know it's a Venn diagram is because my daughter did it last year in sixth grade or whatever, seventh grade, right? They were doing Venn diagrams. And so here's robots. Here's manufacturing. Now, by some measure, you can say all robots are in manufacturing, right? Because all robots were manufactured. No, some of them were just made. Some of them were created without the intent to sell. This is a really cool YouTuber guy that's built an automation system. And it's got, you've seen the Rube Goldberg machines where the balls roll around and do stuff, right? So he's got this Rube Goldberg machine that drops these steel ball bearings onto a drum. And then they bounce off and they get captured and they go around the apparatus again. And then they bounce onto the drum. They go around again. And they bounce onto the drum. And so that's like a drummer in a band, right? And then he plays guitar behind it. And he got it. So that bouncing off the head of the drum, there's some chaos going on there, right? It's not 100% predictable. It could bounce a different direction. And when I was last watching, I think he had something like 100,000 ball bearing drops in a row without a miss. He was getting pretty good at it. Is that an automation system? Now, see, clearly he was making it because he didn't intend to sell the thing. I think he did intend to get lots of people to watch his YouTube channel. So he intended to get some revenue, perhaps, but he wasn't making that to sell it. So he wasn't manufacturing it. All right. So not all robots are manufactured. Was that a robot? So what is a robot? Who's studying robotics here at WPI? Some of you must be. No, all the robotics people are sitting at home watching, huh? Or just decided they didn't need to go to class because they were busy on their robotics project this week. Some of them are sick. Huh. That's because all those late nights working on the robotics projects, probably. Informal survey, show of hands. Do you like the classes that make you stay up late to work, or do you hate the classes that make you stay up late to work? So raise your hand if you like the classes that made you stay up late to work. Really? I get some wavy hands coming up. All right, you're brave. Do you hate the classes that make you stay up late to work, or are you just sort of ambivalent? Anybody hate them? Don't think you should have to stay up late to work? I see a wavy hand here on this one. So I went to school here, and the class that I loved the most out of all the classes I took here was, we were outrageously busy. We had 3 group projects. Each group project required like a 30-page written report at the end. But the project wasn't about the report. The project was about discovering the stuff and doing the work and making the design. And I struggled to get a C in that class. And it's the favorite class that I took here at WPI. And it really sort of taught me what it was like to be an engineer in a working environment doing some stuff. But anyway, maybe you'll think when you look back later, maybe it's because you're in the middle of it right now that you don't like it.
The term of last year, I took intro to materials science, and I really didn't like the professor, but I loved the class. I think despite the professor.
Yeah, that one shouldn't have been hard, though. Intro to material science shouldn't have been a hard class. But when you get to one of the advanced level design classes where you have to actually use creativity and you have to think, and then you have to prove that what you're thinking actually works, that should take some time. It should require you to put some effort into it. So anyways, off topic, back to the topic. Robots. What's a robot? What makes something a robot? Because I will agree, robots are important in manufacturing. They're certainly important to the future of manufacturing. They're important in manufacturing today. They've been important for 40 years in manufacturing. What's a robot? We all know, right? If I say robot, you all have a picture in your mind. Nobody doesn't know what a robot is. So what's a robot? Somebody tell me. An electronic device that has a job. All right, so does it have to be electronic? They typically are today, but it doesn't have to be electronic. It could be all mechanical, but it's a device with a job. So it's an electronic device, or it's a device, typically they are electromechanical systems that has a job. Now, so is a CNC machine tool a robot? It's an electronic device that has a job. Put chips in barrels, right? The output of CNC machine tools comes out the little auger, and it's the chips that fall into the barrel. Oh, wait. That's one of the outputs. They may be considered a waste output, right? What we really want is the finished part that the customer wanted to pay for. So is a CNC machine tool a robot? I see some heads shaking no. But it is a device with a job. So a robot must be more than just a device with a job. What makes a robot different from a CNC machine tool?
Like, the robot is more about like sensing and adapting. It's programmed to adapt based on like sensors.
So it's got sensors, and it adapts. Is that enough? So who's probed the part in a CNC machine tool? Right? Does it use a sensor to do that? All right, so it's got sensors. If you move the part to a different location and you probe it again, does it set the origin over, and can you still use the program? So it adapts. So is a CNC machine tool a robot? We still, in our mind, we still feel that it's not a robot, right? I think most of us feel that a CNC machine tool is not a robot. What about a robot makes it different from a CNC machine tool beyond that? Doesn't require a human. No people required. Oh, come on. Show me a robot that wasn't programmed by a person. But we feel like it, right? We believe that the robots eliminate the need for the human in the cycle. In fact, CNC machine tools are often operated by robots, right? Often a robot is loading the parts in. The robot control system is telling the CNC machine tool, the part's there, it's okay to start. The CNC machine tool is talking to the robot. It says, hey, I finished making that part you wanted me to make. You can take it out now. And the robot goes and takes it out, puts it in a pallet, puts a new piece of stock material in, and says, hey, the part's there, you can start. So robots and CNC machine tools interact together. We could have this discussion all day long, and we don't have enough beer with us. So we should stop now. I could argue both sides of, yes, a CNC machine tool is a robot, and no, a CNC machine tool is not a robot. I could argue both sides. I could argue both sides all day long. Doesn't matter. It's one of the reasons I call this automation in manufacturing, not robots in manufacturing. So we typically picture a robot as a thing. So WPI actually, the robotics program here at WPI, they actually created a definition for what's a robot. That was important. When you create an academic department, you have to actually be able to tell people what it is you talk about. And so here at WPI, it has sensors, it adapts, it interacts with its environment. It's reconfigurable to do multiple different things. So I think one thing that maybe puts a CNC machine tool outside is it's not as reconfigurable as some other robots. But many robots are used as part of automation systems where they never get reconfigured. When it was purchased, there was never any intent to reconfigure it. But it doesn't matter what's a robot, what's an automation system. Let's just talk about automation systems. Automation systems often include robots. Who's ever received a phone call that was not from a person? We can all raise a hand to that one, right? Unless we just don't answer the phone ever. I had this guy, Jason, calling me. Jason called me and he wanted to sell me a home alarm system. He wanted to reduce the cost of my homeowner's insurance by providing me with this home security system. And I was probably 7 or 8 calls in before I figured out Jason was not a person. It's funny because he changed his name. He was Alan last time he called, and he was still selling home alarm systems. Same voice, fairly certain same robot. So is that actually a robot? I called it a robot. Is it a robot? We call them robo-dialers. Does a robot have to exist in the physical world? Why? I think there's debate. By the way, you can get rid of Jason if you ask him what his middle name is. Jason will always hang up if you say, hey, Jason, what's your middle name? He always hangs up. That was how I figured it out the first time. So all right, let's get off, is it a robot? Let's talk about automation. What's the purpose of automation? So we may use robots. We have some uncertainty in what it means to be a robot. There's certainly debate about what it means to be a robot. What do we mean when we say automation? So immediately robot jumped to your mind when I said automation in manufacturing. What if I had said automation in education? What would jump to your mind? Instead of automation in manufacturing, if I said automation in education, what jumps to your mind? 1984. You guys get the reference, right? Who was born in 1984? Just me. It wasn't like that back then. If I say automation in education, what's the first thing that comes to your mind besides 1984? Yes. Using computers and technology to learn more or learn more efficiently, right? Why do we automate something? Somebody shout it. Why automate? To remove people from the operation. But the reason we're removing people isn't necessarily just to save money, right? We feel like if we get rid of the people, it saves money. And often it can. But you said to remove people from the operation because they don't want to. So boring. Or dull. Unsafe. Or dangerous. So we automate things that are dull. We automate things that are dangerous. If humans can't do it or if it's too hard. So one automation tool that's used all over the world in factories are assisted lifting devices. Has anybody ever pulled the motor out of a car? No? Really? Has anybody ever envisioned picking up a car engine? Like lean in over the hood and lift it out, put it on the workbench? Could you envision that? Yeah, it's not good for your back. I accidentally did it with a transmission once. I didn't actually lift it out, but I did have to gently set it down when I accidentally took the cribbing out from under it before I took the last bolt out. Maybe that's why my shoulder hurts. Huh. Never thought about that. So we automate dull jobs. We automate dangerous jobs. The jobs people don't want to do. It turns out we like dirty jobs too. And so dirty could mean dirty could be combined with dangerous sometimes here. So when I was a WPI student, I did a co-op. You guys know about the co-op program here? Do a co-op. I don't care if you're a senior now, do a co-op in the middle of your senior year and then come back and finish. It makes it so much easier to find a job later if you have work experience actually working as an engineer. I did a co-op at Vermont Yankee Nuclear Power Plant. I was there during a refueling shutdown. That was pretty cool. I was the guy that had to dress up in the radiation suit. By the way, the radiation suit does not block radiation. It's not like lead lined. It's to keep you from taking radioactive particles out with you. So it's just plastic. All dressed up in the yellow radiation suit with the little magenta radiation symbols on and all that stuff. The booties on, duct tape. You duct tape the gloves. They use a lot of duct tape. Duct tape the gloves to the suit and all that. So it was a boiling water reactor to keep the cooling water close to the reactor because you don't want to run out of cooling water with a nuclear reactor. That's bad. So to keep the cooling water close to the reactor, there's this donut-shaped torus goes around it, and this got cooling water and pipes running through and all that stuff. Get to row a boat around the torus to mark the spots that had to get repainted. That was kind of cool. But it's probably a reason they had the 20-year-old guy doing that, because he didn't know better than to want to go into a confined space in a highly radioactive area, right? It wasn't dangerous levels of radiation or anything. I had my film badge. I was good to go. Row a boat around the torus of the nuclear reactor. That'd be a job you'd want to automate, huh? Right? The company doesn't want the liability of sending me in there necessarily. It's not, I have a friend that rebuilds old machine tools. And he's like, back in the 1930s, When a guy lost an arm, you got a new guy, right? You can't do that in industry anymore. So when he gets in one of these old machine tools to rebuild, he has to put all of today's safety guards on it. He has to update it to today's safety standards, even though it was originally built in the 30s or the 20s. So, all right, so dull, dangerous, dirty, that's sort of the typical thing we say we want to automate those things. What's manufacturing again? It's making stuff to sell. What gets us paid in manufacturing? Sending the invoice, right? What's the first thing we should automate in our manufacturing company? Sending the damn invoices, right? We shouldn't be waiting to send the invoice. Now, that doesn't require a robot. Certainly not by your definition of a robot. Or maybe you want to put a handwritten note on it. If you guys are not all homeowners, are you? No, when you become a homeowner, you're going to get letters every couple of weeks from somebody that wants to buy your house. Now, they don't necessarily want to buy your house. They just want to buy houses cheap. And some of those letters go to people that really need some cash today. And so those people who really need some cash today may be willing to sell their house pretty cheap so they get the cash today. But the people that send those letters have determined that they don't get opened if they don't look like they're handwritten. So they get robots that will do script on the envelopes. So it looks like the envelope was handwritten. Not just print it, right? You could make a font. You could laser print it on the envelope. That doesn't work. Actually, a ballpoint pen that writes on the envelope to make it look like it was handwritten. That's a physical robot. So we do, but send the invoice would be a good thing to automate at the beginning. What else costs money? What are the costs that we see in manufacturing that we would want to eliminate? So besides getting the people out of the boring and unsafe jobs, because of course we want to get the people out of the boring and unsafe jobs. What else can we automate in manufacturing? Yes. We could automate that process of going from the designer's idea to the tool paths that can make the part, right? So when I get to meet the guys that founded Esprit, DP Technologies, these guys, this is Dan and Paul, that's where DP came from. They started the company in a parking garage because there was a payphone in the parking garage and they would park next to the payphone. They had business cards printed up with that payphone's phone number on the business card so that people could call the company, right? They both worked for other software companies. So they both quit. And they're like, we got our idea. So when I met them, they were doing $100 million a year in sales. They had moved out of the parking garage. Their stated goal with their company was to make their software irrelevant. Their stated goal was to build so much automation into the software that you wouldn't need to actually operate the software. You wouldn't need the engineer to go from idea to toolpath. And they've succeeded at many levels at doing that. We don't teach you that part of Esprit in M1800. We actually want you to use the software to learn about the machining process. So we don't use all the automation tools. But if you've got a fairly competent software person, you can set up a system for your company where you take that solid model, you drag and drop it into a folder, and then someone drags the code onto the machine tool. And the Esprit software has done all the math for you, has done all the figuring out, choosing the tools, choosing the right feeds and speeds, all of those things that we as engineers need to do. They can do that in software. So you can automate that toolpath generation. What else might we want to automate in manufacturing? So we want to automate sending the invoices, right? As soon as the part goes in the box, as soon as the box leaves the shipping dock on the truck, we want to charge the customer. So we don't get paid till we send the invoice. So that's a good thing to automate in manufacturing. It's not the first thing that came to mind though, right? Because I don't need a robot to do that. What else would I want to automate in manufacturing? Creating the code. So taking the idea, creating the program. What else has cost in manufacturing that we don't recapture directly from the customer, right? What adds cost that we don't see value in? Yes. How about we automate some of the quality? So yesterday we talked about this Industry 4.0 stuff. We talked about the fact that the machine tools could be reporting back that the bearing's wearing out on this machine, and the service tech needs to show up in 2 weeks to replace the bearings on the machine or whatever it is. Or if we're flying our 747 across the ocean, we get a text message from GE. It's like, shut down engine 4 now. Now it could fly on 3 engines, but if engine 4 explodes, that could damage some of the flight control surfaces. We don't want to do that. So we're monitoring stuff remotely. We can also automate some of this inspection. What if we took that probe that was in our CNC machine tool, the one we used to locate where the workpiece was? What if during the operation, we went and checked to see if the workpiece was the right finish size? We proved it on the different dimensions.
Does that have some car manufacturers say they have like a 10,000 point inspection? That'd be a lot of time for a human to do it.
Oh, they absolutely are doing something like that. They've automated some of that inspection. Or maybe they say 10,000 points because they took a picture of it that had 1 million pixels in it. Right? Oh, we looked at all the pixels all at once. Yep, it was good. Anybody ever been to a Jiffy Lube or whatever, Meineke or whatever, to get your oil changed? They say, well, we got a 27-point inspection we do, right? And then when they're giving you your car back, they read through their 27-point inspection and tell you everything's okay. Or they tell you that you need a new emergency brake cable or whatever it is. I remember last time I ever went to one of those places, he's going down the list. He's like, yeah, the windshield wiper works, this works, the horn works, blah. I was like, really? Because that horn hasn't worked in 3 years. Like, oh, we don't usually hit the horn when we're in. Like, well, then don't tell me it works. So if that was automated, the computer would have told us whether or not the horn worked, right? That would have been a better, because it would have eliminated the need for the guy who wanted to sell me the next oil change from telling me that he had done something he hadn't done. So let's automate some of the inspection steps. You could use the probe inside the machine tool to go in and check the part. So we have these parts. The part looked sort of like this, and it had some features on it. Different features on it. And we were cutting it out of a piece that looked sort of like this. And the cut time on the part was a little bit over 24 hours. We didn't want to spend any extra time figuring, and the size tolerance on this feature and maybe this one over here, and then the distance from that surface was plus or minus 0.0001. So 2 10,000ths tolerance on the location and the size of those features in a 24-hour cut time. And the workpiece is ceramic, so the tool wears out just about as fast as the workpiece wears out when you're cutting it. And so we had it set so that the operator would put it sort of in the middle of the fixture, press the start button, and walk away from the machine. The machine tool would then go out and it would probe it and locate the center. It would do a couple cutting passes, then it would probe to see how much material was removed. It would adjust the cutting parameters based on how much material was being removed with that tool at that time, do a few more passes, and it would keep going in and checking with the probes different critical dimensions. We did like those probes that we use over here, about this big around. The tip on our probe was 1/4 millimeter across that we were using to go check those surfaces. All right, so we go in there and it would cut, check, cut, check, cut, check until it had made the shape that it needed to make. So we automated the process of making this part so that we could get this tolerance without having to have a $40 an hour machinist standing there all day long measuring the stuff. So you can automate some of the inspection. That was a good one. What else might we want to automate? So we're going to automate toolpath creation. We can automate sending the invoice. We can automate some or all of the inspection steps. Certainly, if we're making thousands of parts at a time, we can automate the inspection steps. If we're making 1 or 2 parts, it maybe doesn't make sense to automate those inspection steps. What else are we going to automate in the machine shop? Because maybe for inspection, we're using a robot, but we haven't used a robot yet. Even though the first thing that came to our mind when we said automation of manufacturing was a robot making a Chevy Citation. Anybody seen a Chevy Citation ever? No, I didn't think so. They haven't made those for a while. It was a car. What else could we automate in manufacturing? Yes.
Loading and unloading stock and parts.
So putting parts in the machine, taking parts out of the machine, right? So we finally get to use our pick and place robot or our 6-axis robot to put the parts in the machine, take the parts out of the machine. Now, really, because we do CNC machining in this class, when I say manufacturing, you think CNC machining now. That's a little bit my fault. It's totally all your fault. You got to remember that manufacturing is not just CNC machining. It's just the example we use in this class. But putting parts in the machine tool, painting the parts, taking the parts out of the machine tool, folding the boxes that the parts are going to get put into before we ship them to the customers. Right? All those kind of things that don't really add value to the part, we can automate those things. What else do you think we could do? Let's think about a job shop, a shop where there's lots of different people asking for quotes and prices. There's different numbers of parts. Maybe this guy wants 7 parts. Maybe this guy wants 7,000 parts. And we got different jobs that we're changing over all the time. What else might we want to automate in a place like that? Yes.
How you choose what jobs go on what machine?
So the scheduling of which equipment we're going to use. We may want to be able to automate that. What else might we want to automate? That's the one I want to automate first. So when the customer asks you for a price, when they ask you for a quote for that part, what do they want? They want the part. They don't really want the price. They're asking for the price because they understand the process. They don't want the price. They want the part. And so the longer we take to figure out the price, the less likely we are to get the job. And the longer we take to figure out the price, the more it costs us. So if we could automate that creation of price, some of the first attempts to do this would be, well, what's the mass? What's the mass of the stock material? That's pretty easy to figure out, right? You know what the stock material is. You could calculate the size of a shoebox that the finished part would fit in. Therefore, the finished part fits inside that piece of stock material, right? And what's the mass of the finished part? So how much material are you going to remove? Right? And then you could quickly come up with a way to figure out prices based on the amount of material that's going to be removed. We often did that for estimating the cost of machining ceramics because we knew that it cost this much per gram to take material away from the ceramics. What's the fault of that estimate? What's the problem with that estimate?
You have to do like really delicate stuff.
Right, it doesn't consider the complexity of the part. So first you go with this, like, how much material are we removing? Then you want to figure out what's the complexity of the part. What are some of the complex things we have to figure out if we want to automate the quote generation? Besides material removal, like how much material can we remove? What else might we consider? So what are some of the things that add complexity to the part? Yes?
Number of flex surfaces.
Number of faces that need to face a different direction, right? So how many times do we have to physically put it in the machine tool to make all the surfaces that we need? Then how tight are the tolerances, and how tight are the tolerances on how many of the features, right? Because if the tolerances are down in this range, you're not going to ship it without measuring every feature that has that tolerance, right? If it was in this range, you measure one of the features. As long as that one feature is okay, you can probably ship the part. So all of those things add to the complexity, which is why the really good automated quoting platforms use AI or machine learning. Same thing. We talked about that yesterday, right? That's part of Industry 4.0 is how can we use this machine learn? Now, all of those things we talked about help us consider the cost of making the part, right? What should the price be? It should be greater than the cost. Can we just assume that if we cannot make the price be greater than the cost, we probably should say no to the customer? That's tough. The old shop owner says, you lose money on every job. How do you stay afloat? It says volume. There's another one of those jokes you guys are supposed to laugh at. I think I'm gonna cry if you don't laugh at some of my jokes.
Wait, how does losing more money?
Yeah, no, it doesn't work, right? That's what makes it a joke. You can't make up for losing money on every part by making more parts. You just lose money faster. You can't. That was what made it funny. It actually is what causes inflation, isn't it? All right. So if we analyze manufacturing and we think about what we should automate, we were on our third thing that we came up with before we might have wanted to use a robot. Right? Is when we got to inspection that we might have wanted to use a robot. I love robots. Robots are cool. But they're not necessarily the first thing we want to use when we get into automating manufacturing processes. And so, yeah, loading parts in the machine tools. The other things that people use robots for in manufacturing, amazingly enough, is sorting parts. Now, if we have touched it once, can't we just put it in the right place so it doesn't have to get sorted again later? But no, we're horrible at that. We'll make a bunch of parts, throw them in a box, ship the box to the customer, and then the customer's got to pick out the parts, put them in the right orientation when they come out of the box. So we're horrible about stuff like that. Sorting parts, palletizing things, stacking things. We use robots for those kind of things often. In the inspection part, you get an assembly line or a conveyor where the parts are just flowing past. And that robotic or that vision system that's maybe connected to a robot, maybe not, but this automation system is looking at all those parts with a high-speed camera as they fly by. They say, hey, that one looks defective. And all of a sudden, a little chute opens up, and that one shoots out the side. They don't keep that one. So throwing out, remember we said, just don't ship the bad parts to the customer, right? If you don't ship the bad parts to the customer, then the customer is going to like you more. So one of the ways we use automation is to check to make sure the parts are good. You wouldn't want to get a beer bottle that was half full, would you? I mean, you guys, but you could imagine. Maybe it's a soda pop bottle that was half full. So they use vision systems and lasers and stuff to make sure the bottles are full as they go down the line. If they're not full, they kick them out the side. Right? They can reuse the bottle. Some of the parts they can rework. They can fix if it's a mechanical part going down the line. So these are the kind of things we're going to automate. But if you're going to do automation in your manufacturing system, think of the things that will have the highest ROI first. And we don't often want to automate to eliminate people. We want to automate to get the people out of the dull, dangerous, and dirty jobs and get them doing something more valuable. Because our assets, our corporation's assets, are the people that go home every day at 5 o'clock. All right, with that said, lecture's over. Yeah, I'm not going to tell you the funny story about the bottles that are half full. It's not appropriate to lecture. But it